that is probably next to the table saw the next most dangerous thing you can do, because you have no guards, you have no protection whatsoever, and you definitely do not stand in line to the side of either side where you're turning, because there's nothing to prevent whatever is in your lathe from leaving the lathe. So you would assume, regardless of how good a job you do with a bolting to a safe plate or using a chuck on here, is that can come loose at any time, and I won't call it a loose cannon, but it's the second best thing. But it's great for turning large trays and tabletops. The biggest piece I've turned was a 44-inch mesquite tabletop. Now that's not one piece of mesquite, because you're never going to find a single piece of mesquite anywhere near that big. But what I started with is a similar synthetic material and glued pieces of mesquite to it to make the blank. Now it was not turned, it was turned on a lathe that could not have the head swivel.
Yeah, I think that's a good place to jump in. Yeah. There's a lot of different approaches to outboard turning depending on your lathe manufacturer. You can see our lathe here, we just slid the headstock up to this end and we're out over the end. There's some of your older lathes, and we'll talk about what this causes, different complications it causes, have an attachment on the back of the motor, on the back of the spindle with left-hand threads, and you turn, the headstock doesn't move, it sits down here all the time, and you turn off this end. Grizzly and a couple other ones make a headstock that turns either 90 degrees and you work here, or it can turn 180 degrees and you work off the back. Whenever you start getting to working off of the rear of the headstock instead of the front, doesn't matter if it turns or not, then you're faced with the left-handed threads. As long as you're on this end of the headstock, when your lathe is in forward, you're trying to tighten this. And one thing you mentioned about safety, there is a lot of inertia on a big piece like this. Some lathes have internal braking. And I don't know how many people have, even without internal braking at home, I occasionally will grab mine has a hand wheel to slow it down. Well, you want to turn off the braking, and you want to avoid doing that, because this can just unwind, and it gets pretty exciting for a while when you're turning, unwinds, comes down on the floor and starts running across the shop.
Well, the other thing is put a set screw in here. I put a set screw in.
Yeah, see, I don't know. Maury's talking about set screws. You can put a set screw in. Some lathes have a little spot for a channel to put a set screw in. Others, the set screw goes right in on the threads, which I don't like.
No.
And but you can put a lock screw in. That's definitely going to help keep it from spinning off. Along with the different approaches for how you get yourself outboard, is different approaches on the tool rest. The Grizzly that I told you about that turns 90 degrees and you stand here in front of it, it's got an articulated tool rest, which there's a piece that goes in the standard banjo and comes out about 12 inches and has a receptacle for another tool rest. So you kind of working around the corner on your work.
I will say about that articulated one, it is not really, if you get a good catch, you're going to bend that sucker.
Okay, Bob's questioning the strength of some of them,
yeah,
especially if you get a catch. There are some lathes, and I'm not going to tell you the names because I don't want to advertise for them, or better yet, I can't remember which ones they are. But they have a bed extension that attaches low on the leg and comes out here. So you can't go clear to the floor or do a
No.
44 inch, but you could probably do 36 inches on it by putting that bed extension. And then you just use your normal tool stuff. What we have here is a freestanding tool rest. And you can come up after the meeting and look at this if you want. It's got a tripod leg. You can buy these. This one's not a new one by any means, but they still sell these. I think Delta sells them. And this can be placed just like we have it here, and everything's just like it would be on your lathe, except this one just has a set screw into the tool post. And let's see, there's one other type of dedicated or of outboard turning I didn't mention, and that's with the what's called a dedicated bowl lathe, or the VB36, like Larry Miller has in his shop, and I have one in my shop. They were made to turn bowls, and they have a different kind of a tool rest altogether, but allows you to turn large diameter stuff like this.
There is another consideration, is that there are very few lathes that will run slow enough to turn these big outboard pieces. You cannot start fast with one. And if the piece is big enough, you can't, with the given speed of the lathe, the slowest speed possible is not slow enough. The vibration will be, until you've turned a piece on the lathe that is heavier than the lathe really should have on it. That's a very exciting experience. I had a home built lathe that I was turning 140 pounds of maple, hard maple on it. And I can tell you right now, I even had a secondary pulley set up on the thing to slow it down. And the bed was 8 feet long on the thing, and had the base, the headstock and the tail end of the lathe had pieces that you could stand on them and put your weight on them. And I'll tell you right now, that's not enough, because that lathe, without, at the slowest speed that it would run, with that much weight rotating on that, the centrifugal force was enough that it actually was lifting the lathe off the floor once a revolution. And this was even after it had been turned down, because when you get that much heavy wood on there, the wood density is not the same all the way through, and that's where there's a difference in the weight. I had one that I was turning what they call a mook. It's a big heavy piece with 2 arms on the thing, and it's used for Oriental martial arts. And these guys would take and they'd whack this thing with their open hands. And I mean, they could. One guy actually bolted the dummy to a garage wall, and eventually destroyed the garage wall just from the pounding that he had done on this thing. This one guy, I turned 3 of those for a guy, and we always started out with the lathe with him standing outside on that base to keep it from, because the lathe would come off that far off. Once a revolution, the lathe would raise that far off the floor.
Yeah, the one Oliver I have, the manual says can turn 48 inches.
Yeah, lots of
The
luck with
slowest
that.
speed is 1,000 RPM.
Yeah.
There's
No
absolutely
way.
no way. So what can you do to help your lathe? One thing with this lathe is I would get rid of this stand.
Yeah.
Because you can see that it just,
Yeah,
that
the
stand
vibra-
leaves
yeah.
it rock. My lathes at home that I turn big stuff on, I have them bolted right to the concrete floor. They don't go anywhere.
Yeah.
But sometimes that's not practical. Another thing you can do is take a piece of plywood, say a triangle piece of plywood, and bolt it or clamp it to the end of your lathe so you can expand the length of your footprint to help get rid of that vibration. A lot of people put sandbags or some other kind of weight in the leg to dampen it. But the movement of the lathe is especially critical when you've got a tool rest that doesn't move the same direction as the lathe does. Because some lathes, even if they're not coming clear off the ground,
Yeah.
will just kind of walk. I don't know
Yeah.
if you've ever seen that in one of your lathes, but they'll just kind of walk if you got a lot of vibration in them. So vibration is one of your enemies on any kind of turning, but especially on outboard, because you got that extra diameter that multiplies your vibration.
And most lathes you can't, if you put, I would say in general, if you put anything in larger diameter than this on the lathe, particularly if you've got a blank that would weigh, let's say, 25 or 30 pounds in there, even once you start turning on the thing and you get it so it's symmetrical, it's still out of balance because the wood density is not going to be the same throughout the piece. So it is going to be like having a counterweight out on it. So the vibration is probably the hardest thing to deal with. But that's, most lathes are not built to run at slow speeds. So look at almost all your ads. You're talking about what, 400 to 600 RPM is the slowest speed that they rate them at, which is really not slow enough.
Yeah, this lathe will go slower than that, but even lathes that go slower than that, we can, at this point, you don't have any torque.
No.
And you've got to have enough torque to get your
Yeah.
lathe. That's why people, I've had this question a number of times, well, my lathe's variable speed, electronic variable speed,
Yeah.
why do I have three pulleys in it or 2 pulleys in it?
Yeah.
And that extra pulley is to get your
Yeah.
power curve of your motor to where you're going to be using it. Right now, this one looks like it's hardly moving at all. That's still 200 RPM. And we're turning something that's practically perfectly balanced. I mean, this type of wood doesn't have the density problems that, no. As far as turning tools, when you've got your lathe set up like this, or set up in the front, you're going to be using the same type of tools that you normally do. When it's in the back, you've got two considerations. One, you're not going to be turning on this side of the wood, you're turning on the other side because your spindle is the way you're looking at it is turning backwards. So most of your tools are going to be the same, but if you're turning a bowl and you use a bowl scraper like I do that's got a radius on, you're going to want the opposite radius on your tool. Another concern that I have with these type of, I've got almost too wide of a tool rest on this in my mind because
Yeah.
it's
The leverage is
it's got a lot of leverage. You don't want to get something out here that's going to tip your tool rest because I wouldn't want to guess where the
where
pieces
it's
are going to
gonna
go.
You're not going to know
So
where it's going to go.
This one here is, see where the long leg is coming
Yeah.
out towards you?
Yeah.
That was set up for turning on the back side
Yeah.
because that long leg gives you the most resistance to tipping. Probably even better yet would be to use a smaller tool rest. Keep that
Shift your support over where you're turning,
right.
so that your tool
Is
as close as you can get to the center of your support.
Yeah,
the point that you're turning, even to the, having to move the whole assembly while you're on the lathe on there.
Okay, John's just giving me a picture
Yeah.
of a
Yes.
fairly large outboard
Yeah.
turning.
Yeah.
We'll just pass that
Yeah.
around. Has anybody in the audience done any outboard turning? Okay, we've got a couple people. Maury, what type of system does your lathe
This one I had an English record, and it turned sideways,
sideways like the Grizzly I was describing?
and it had two banjos. It had a long one and the normal one.
Okay, Maury's saying that his lathe turned 90 degrees and he had two options for the banjo. And Lloyd, you say you've done some outboard turning?
Mine's a Grizzly, so it just had to spin on the backside.
You used the left-handed threaded,
I had an adapter made to reverse that.
oh. So you had a left to right so you could use your right-handed. So you were running the risk of unthreading. Did you use the set
No.
screws?
No, it should not unthread. In fact, sometimes it gets too tight.
Okay.
You turn some at Campbell School, but they use to just flip the end. So you're
So turn it 90 or 180 degrees and work off the back. There's a lot of different options. Most of the mini and midi lathes, like we've got sitting along the wall here, do not have that option.
No.
They've got a fixed tailstock,
Yeah.
headstock, and you don't have it. There's a lot of your slightly larger lathes will have some way to do the outboard turning. And it can be fun. You don't have to do the 44-inch diameter plate for your first project.
No, no, that's not a good idea to start that way either. You want to get a little experience before you start experimenting.
Rod, your lathe has left-handed threads on the back, doesn't it? Does it have a hand wheel? Okay. Rod's got an Oliver, and that hand wheel is drilled and tapped to use as a faceplate.
Yeah, I've
So you-
got,
Not me.
yeah, yeah.
Okay.
My Vega has a solid aluminum hand wheel that is essentially almost like a faceplate on there, and it's drilled, and I have used that, but that's with an outboard mount, which the lathe was never designed to be used with. That's where the 2x4s, angle iron, and a batch of clamps come in, because that's where if you want to do a lot of outboard turning, you buy something like that. How much do these things run?
Probably $200 to $300 in that range.
I would expect. If you're only going to do one or two pieces, you jury rig something that. But I had one that was really cobbled up. That 44-inch table was really wild. That was on a home-built lathe, and I had to add a jack shaft and another set of pulleys to get the lathe speed down where the vibration wasn't so bad that you couldn't cut on it, because that can get that. If the wood is really too heavy for the lathe and you can't slow it down, there's really not a whole lot you can do that's safe. Even though you do some handwork to get rid of some mass of the piece you're going to turn, it's really a very dangerous proposition.
If you were going to try a first project, what I would suggest is maybe a platter.
Yeah.
A platter that, if you've got a 12-inch lathe, maybe try a 16-inch platter.
Yeah.
You can get those cut fairly round with your bandsaw, and there's not a lot of thickness there, probably 1.5 inches
So
or
you
so.
don't have a lot of mass, therefore you
Yeah.
don't have a lot of a whole lot of vibration.
Yes, Lloyd.
My question is it best to have freestanding or attached?
The question is, which is best, freestanding or attached? Well, there's advantage to each one. The most solid one would be the one that has the lower, bed extension.
Yeah.
Now that's still limiting you on the diameter to that bed extension, but that is rock solid. There's
Yeah.
no doubt about it. The other attachment is with that articulated banjo arrangement, and I agree with Bob that I mean, I've got that, but it just does not look like it is the most substantial thing. I've never bent it, but I just don't have a lot of trust in it.
I think it leads to a lot of catches because it's flexible when you.
This, I like this system here because I can move it wherever I want, and if I want to work on the rim of this, I can just pick it up and bring it right out here and work with it. The other advantage of this type of rig is it's got a fair amount of adjustment, so it'll fit a variety of lathes, which it's very important, especially on the outboard turning, that you get your tool height at the right level. So you don't want to try to make an adjustment if this isn't high enough. You don't want you get your tool down like this to go across the middle.
You can get a catch at speed with a piece this big a diameter or larger out toward the edge is going to be catastrophic. You don't stab your work with a tool because it's going to catch, and it's not going to be a nice thing to, particularly if it's an expensive blank that you've got. Particularly when you're turning big pieces like that, you rarely are going to have a single solid piece of wood. You're going to have a blank that has been glued up. And a lot of times when you're gluing up a blank, you can get rid of most of the mass that you would normally have to cut away with a single piece of wood. So you can initially cut down a lot of the vibration that you would expect from a large turning.
And we've talked a couple times about catching, and there's some of us are saying, I don't catch, but but when you do get a big piece, especially if it's not something you glued together, if you're even just facing off the front, you're going to have what's called an interrupted cut, where you're cutting wood and then air and then wood and then air, and that's by itself is bad. But when you slow your lathe down real slow, there's a tendency with a lot of people when they hold their tool that when they hit that air spot, the tool goes in. And that's why when you have a interrupted cut, if your piece is small enough, I like to get as much speed as I can. That limits the amount of time that air is in front of your tool for it to drop in. But if you're turning at 200 or 150 RPM, you've got a lot of time for that tool to go in. Or if it's I was talking about facing, even if the outside is not round, you can really get a nice catch there. At that point you want a tool rest that can get as close as you possibly can to the stock that you're cutting, because it gives you have the maximum amount of leverage. Now I don't like to turn with short tools. I like long handled tools, because for one reason is that when you're turning and this is with the normal turnings on a lathe as well as outboard, is that you want that leverage out here. For example, if I were turning something with that I couldn't get any closer than this with my tool rest to outboard piece, I'd probably give up before I started, because that with you couldn't stop a catch there, because you're not, even with a long tool out here, that
end of that tool, at the point that you'd contact the wood, it's too much travel. You need to get that down to where that you have better control than that, and you definitely don't make big cuts at that, because you can't help but to have a bad catch with it.
So I asked a question to the audience a minute ago. I'll ask a different one. How many people can turn outboard turning on their lathe that they have now? Okay, we're seeing a lot of hands here. It's physically impossible? Okay.
How do you get that kind of luck?
Yeah. Rod, I didn't see your hand.
Now that I know, I guess.
Yeah, yeah.
I'll go to
So-
Mark.
Very
I'll
unaware
go
of
to
it.
Mark, see something come flying to the wind.
So I know our challenge for next month is to turn something outboard, and maybe not everybody can. That still brings something for show and tell, but I think it would be interesting for, when we saw that only, I guess, 2 people in the audience had ever done
Well, I
outboard
guess-
turning, and,
I can't get down to even 500 RPM, so maybe I can.
Well, that's not bad if you're dealing with lightweight pieces. If you're dealing with something with a lot of inertia, particularly along with the vibration that you get with out of balance pieces, it's more than exciting. It's really dangerous to even start turning.
Bill's question, for those of you that didn't hear, was his lathe doesn't even go to 500. What, maybe 600 RPM, 550, 600?
Yeah,
And
and that's
is this-
when I have a new belt on.
Is the slowest he can get with
That's
his.
pretty typical.
Goes all the way up.
Look at your specs for the lathes, and you're going to find that from 450 to 600 is a very common slowest speed that the lathe, the way it comes from the factory, is going to go.
Lloyd has a question, yes.
Isn't that speed you're talking about registered at the spindle?
Yes.
Not at the outer edge?
No, the outer edge, you're talking surface speed.
Yeah.
We've just been talking RPM.
Yeah.
When you get the
Shaft-
surface speed,
shaft
it's
speed, yeah.
how many inches per revolution per, or per minute, rather. Instead of revolutions per minute, it's inches per minute. So it just keeps, the farther out you go, the worse
faster
it gets.
The speed at the point of contact of the tool, the further out you get, the faster it gets, and that's why a lathe that I would not want to start with this kind of a tool rest with this diameter of a piece on any of the commercial lathes, unless the electronic controls, that you can get them down to 100, and you don't turn in a hurry at 100 RPM. You have to take your time, and the further out you get from the center run there, the more time it's going to take, because you do not take heavy cuts out there, because one thing you can't do is if you start taking heavy cuts, you really can't control the feed rate of the tool, because it's going to be self-feeding. There's going to come a point that you're going to think there's somebody on the other side pulling that tool in, and it will catch.
Okay, this lathe advertises it'll go as slow as 50 RPM. That's 70 right there. It's got some torque.
Yeah.
I can't. Okay, there's 50 RPM. I would, for something this well balanced, you wouldn't turn it that slow. But something big, that is,
Yeah, you don't want to make a career out of just getting rid of waste wood on a turning.
but for your first turning, I would use something that is already fairly balanced to start with. I think your 500 RPM.
That's a 3-phase motor, right?
This one, I think it is. It uses an
So
inverter.
therefore, what you said before about at slow speed you don't have any torque is not correct. With a 3-phase induction motor, you have the same torque at all speeds.
Yeah, I can't.
If you had a DC motor, because some of them have DC motors.
Yeah.
Mm-hmm.
If you have a DC motor at low speeds, then you control the speed by the voltage.
Yeah.
And at the slow speeds, you do not have any torque.
Yeah, we got a question.
In reference to the brochure there, I noticed that he had all kinds of shape pieces
Yeah.
that are way out of balance.
Right,
Well, he uses weights on them to,
right. John,
he sets it up as a bounce thing. I've never seen it done.
Yeah.
But somehow or another he puts weights on he has a big piece of plywood.
Mhm.
And I have to assume that there's some type of metal device on there. that you
well,
can
let me repeat your
attach.
question so we can hear it John's talking about counterbalancing for out of balance and pieces, and that is a common thing. And there's a brochure going around where a guy does a lot of pieces of it's useless, so it's got to be art.
Well, it's 92 inches for that one piece.
Yeah.
And some of it has natural edges. Well, there's no way you're going to get a natural edge piece balanced, but you can if you have it mounted to a plate. And I've seen some with adjustable balances that you can move that weight. You can get a lot of that balance out.
You can compensate. You can compensate on there, and most people's normal turnings, they're not going to turn a lot of stuff outboard. It's really it's not if you're used to turning for relaxation, outboard turning is really not something you want to do much. Yeah, Bob knows that because that's really nerve-wracking to be standing there and not knowing where things are going to go when they decide to come apart, and with that surface speed at the lowest RPM that this thing will run at, that surface speed on a 4-foot diameter piece in there is not much short of supersonic, and it makes it a very dangerous proposition with big heavy pieces. I don't think I've turned more than a half a dozen big pieces outboard. It's not an enjoyable pastime to deal with that, because it is a dangerous, however you cut it.
2 feet out, it'd be over 600 feet per minute.
Yes, right.
But what we said earlier, your outboard turning experience doesn't have to be a 30 or 40-inch piece.
No.
It can be something that's a 16-inch bowl.
Yeah.
I've got a lot of bowl blanks at my house that just would not fit on this lathe, just a little bit too big. And it's a couple of ways you can approach that. You can cut them down on your bandsaw, they fit,
Yeah.
or you can try an outboard turning and go from there.
I will say also, in the class we took at Campbell's, before any of us could turn, even though we're all experienced turners, the instructor sharpened the tools. Because at low speeds, that tool is 10 times more important to be sharp than it is
Yeah.
at high speed.
Yeah, Bob's talking about how important it is for sharp tools, and that's right. And the other thing that you got to consider is when you're cutting out here, that tool is going to get dull a lot faster
Yes,
than
it
when you're
is.
cutting in
Yeah.
here.
Yeah.
Because all that material is removing. So it's sharp tools and keep them
Gotta keep
sharp.
them
Okay, do you have any?
That's
I think we've covered most of what we
Most
had.
of
Does
it.
anybody have
any more questions?
I'd like to have some questions. Yes, we have a question.
Does that stand we have there, you're using there, does it weigh a lot, or what keeps it down?
No. Yeah, I guess maybe 50 or 60 pounds,
Yeah.
something like that.
Yeah.
It is fairly heavy, yeah. And that's one of the advantages. The weight's going to, the more weight you have, the more stable it's going to be.
And
I
there's-
was looking on the internet just the other day, and that's why I was thinking it was $200 to $300.
Yeah.
Delta's is a little bit different than this. The legs on this one, if you get a chance to look at it, they're attached pretty much at the bottom of the posts are only
Yeah.
about, what, 5, 6 inches off the ground.
Yeah.
The newer ones, the legs come up higher, I think would give you a little more stability. It's still got the same, and it's got a little bit bigger footprint. The footprint's probably more
That's
important.
not bad, because here's what you can do. If you're concerned about the stability of the base, particularly with the tripod on there, build a shelf 2 or 3 inches off the floor, build a box and start putting sandbags in there. That will probably the single most effective way of stabilizing
Yeah.
of stabilizing your outboard tool rest. Get that weight down and get it enough to where what you want to do is have the base so you don't have to constantly worry about it. Just don't bother with the worry. Build a, even if you took build a plywood base, build it with sand. Kind of hard to move it around, but it's not going to go anywhere. You get 200 or 300 pounds of sand in the bottom of the base like that, and it's going to be a lot more stable than this would be.
A good question, thank you.
I'll make another comment. Barkby that the brochure's on, he had, at one time he had, what's the common lathe, not the one way, Powermatic, big Powermatic.
Yeah, huh?
Had it lagged to the floor, had sand in it, and still got away from it. I mean, it pulled lag bolts right out of the floor.
Yeah, Powermatic does make an independent outboard rest for their.
That's what he had now. That's not shown on here. Apparently,
Yeah.
he has a different type of system that's attached to the floor. Apparently, now not too many years ago, he built a house, and I'm not sure he didn't build a piece of steel underneath his concrete floor and welded pipes to it to come up
To tie
mount
to,
the floor
yeah.
too. So in order for it to get away now,
Yeah.
he's gonna have to break those welds and pull that thing right out of the.
Yeah.
Did you ever see a picture of the guy that using a farm tractor? Now, I'm not talking the small one, I'm talking about a full-size farm tractor.
Big four-wheel drive job.
That was using the drive axle, not the power takeoff, the drive axle to turn
A 12 or 16 foot.
huge
huge
pieces, yeah.
Yeah, some of that's out of our
Yeah, well,
range of
there's one you
capabilities.
See, there's where you'd have the torque at. Because that would be probably I wouldn't doubt 125, 150 horsepower tractor.
probably like, yeah, it would be that
Could be
big.
200, I
Yeah.
don't know,
Yeah.
but anyhow, it's
Yeah.
up there. Then there was also a guy who was doing some turning using the front wheel drive of a car too. A Canadian that was trying this here.
Yeah,
And he used, he made a face plate on the rim. Okay, and then somebody was in the car holding his steering wheel solid, and he just had the one corner jacked up on it. I guess he had the other wheel, probably somehow or another applied the brake to it at one wheel, and had all the power. And he was using a snow plow as his tool rest. Some crazy Canadian.
John, if you want to try that, you go right ahead. All right, anybody else have any questions?
So the main reason for turning something that hard, is it just to prove that you can do it?
yeah, that's usually, when you get, I can attest that's really the motivation of making Rube Goldberg lash-ups on the lathe, is to just, you think of an idea, and that's just proving that you can do it.
Well, maybe what John was
Not
talking
practical,
about, but
yeah.
just using the outboard system itself,
Yeah,
I have a lot of people that like the nice 20 and 24 inch bowls.
Yeah.
I just cannot turn one on over the
Yeah.
the ways. The only way you can get the, I don't know what this is. This is 22 inches diameter. If you had a desire for a 22 inch bowl, this is about your only option, is to do something outboard with most people's lathes.
There's a turner in South Texas, or in Central Texas, that has a home-built lathe, and he has a removable axle underneath, so he can go for demos, and he tows his lathe, and when he gets there, he removes the axle from underneath. He turns hats, wide brim hats. And he turns like big, deep vessels. His turning tools are 8 feet long. He has 2 tool rests, one here, one out there. The tool is laying in it, and he's feeding this thing by hand into these turnings.
So what if you made a lathe that the axis was vertical?
Mm-hmm.
I know where I used to work, they made turbines in Westinghouse. And they had lathes, well, they were turning stuff 12 feet in diameter.
Yep.
But they had to make the axle vertical because there was nothing, if you did it horizontal, just the weight of it would
The weight
bend
of
it
it,
down
yeah.
itself, and you
Yeah.
would never end up
Yeah,
with a smooth piece.
yeah.
So because the weight was so great, you had to make it, but then, I don't know how you would,
Every-
But that's a controlled, cutting tool though.
well, that's a steel thing,
Yeah.
yeah, and
Yeah.
No, that would be
but even with this,
interesting.
I was thinking, maybe that,
Mm. If you decide to give that a try, we could schedule
Yeah,
you for a shop tour next year.
Yeah.
And
well, you mean schedule me for a room in the hospital?
well, maybe.
You know,
Maybe.
the other thing is so you do that, you wouldn't want spectators there with this thing this disc rotating in the same building with human beings, would you?
Well, it'd be like a merry-go-round or Ferris wheel. or
What would be the difference whether it was vertical or horizontal? That still is a disc rolling around.
Well, yeah,
Now you're sort of limited here.
no, you don't, you
Whereas
could,
the other way,
well, the other one could go anywhere.
Anyway, yeah,
Uh-huh.
that's true, yeah.
Okay. Last chance. Anybody? Joe, are you going to go home and turn outboard for the next meeting? You got till January. This is a.
Actually, unless you give me a piece of wood, no. I don't have a piece of wood that big.
Do you have any glue? Okay. Well,
Good answer.
So what are you gonna make out of that piece?
oh, this piece, that's a good question. This is not for outboard turning. I just brought this along as a demonstration of a piece that's bigger than would fit on the lathe. I use this at home I have a bigger lathe than this, and when I do the bottom of a bowl, after I've done the bowl and I want to finish the bottom, I will put the bowl up against here and bring my tailstock in and just pinch it between the tailstock and this plate, and then I can do all the bowl except just a little bit where the center is. And I have these lines on her just to help me get it positioned the first time to center it up.
That's on the big English one. That's on the big green.
Yeah, that's the one I use it on, the VB. And it does work nice. Thing it will do is it will tell you if your two centers are lined up. If they're not, you'll hear this squeaking
Yeah.
every time it goes
Yeah.
around because they're not
Yeah,
perfectly aligned.
It shifts.
So
Yeah.
yeah, it's important to have them in line, and then this does a nice job. It doesn't have to be this big. You could make one of these for any size lathe. It just eliminates the need to make a jam chuck or and I wanted something that was too big for the Joe, what's the name of the the one with the pins that,
Long
Cold chuck.
cold chuck, yeah. It was too big for my cold chuck, so that's why I put this on. Anything else? Well, if not, thank everybody for coming. I hope to see everybody at Christmas time. Yeah, thank you.